Hello everyone, we are discussing circular motion, and in circular motion we have developed the concept of uniform circular motion and non-uniform circular motion, and similarly the concept of angular velocity. Let's discuss angular acceleration. Write down the heading angular acceleration. Now, just to get an idea from you how much you understand the previous lecture, angular acceleration, it should be present in UCM, that is uniform circular motion, or NUCM, non-uniform circular motion, or both. What do you think at this stage? Without me telling you anything, if I ask you a very simple question like this, angular acceleration, I haven't told you anything, but everybody has some gut feeling, so you can tell me what is your thinking about angular acceleration. This type of acceleration should be present with UCM, or it should be present with NUCM, or it is present all cases whatsoever they are. Almost everybody has said both, except one guy, and he is the only guy who is correct. Angular acceleration is present only with NUCM. It is not present with UCM. But just don't worry, I'll explain things and hopefully you will understand. So we have an object, and this object is moving tangentially with V in a circle of radius r. It has certain angular velocity omega. V is simple velocity, or you can call it tangential velocity. Omega, you know, we call it angular. Omega is called angular velocity, tangential and all. Now, if I say acceleration, you go for what? Rate of change of velocity. And if I say angular acceleration, then you should go for rate of change of angular velocity, which is a very obvious thing. So what is angular acceleration? This is rate of change of angular velocity. Write down the statement. Angular acceleration is rate of change of angular velocity. This angular acceleration is represented by alpha. So what is alpha? Alpha is d omega by dt. What is acceleration? dv by dt. So what is angular acceleration? Rate of change of angular velocity. उसी लाइन पर चल रहे हैं हम लोग, केवल एंगुलर टर्म ऐड कर दिया है. So when you say alpha is d omega by dt, and I say that suppose this is UCM. Suppose if this is uniform circular motion, then v, tangential velocity, it will remain magnitude part. If I say velocity, it's not correct to say that v is same, but the speed part, the magnitude part will remain what? Same. So UCM, it tells us that magnitude of v is same. Speed doesn't change. V, it does. V means what? Direction also. Now, write down in the comment box. Let me see if you remember this or not. For UCM, is omega same or no? For UCM, V is not same. Direction is changing. Speed definitely is same. That's a fundamental thing. My question is omega same or not? Is this statement correct? Angular velocity, you can put a vector sign also, doesn't matter. So is omega same or not? What do you think? Yes or no? Write down in the comment box. I'm talking about UCM, remember. For uniform circular motion. And I don't know why everybody is saying no. Everybody is saying no. What is omega? Angular velocity. Rate of change of angular displacement. What is the direction of angular velocity for this figure? Write down the direction of angular velocity for this figure. If an object is moving like this, then what is the direction of angular velocity? Write down in the comment box. This is something which we did in the very last part of the previous lecture. At the very end, we were discussing the same things. When I told you there are infinite values of v, but there is only one value of omega. I hope you remember that part. There are infinite values of v. Direction wise, there are infinite values. But if your speed is constant, then anywhere you go, rate of change of angle. Anywhere you go, rate of change of angle. Anywhere you go, your rate of change of angle, it will be what? Same. And how do you decide direction? Take your right hand, curl along the direction of rotation. This is the rotational sense. What what type of rotational sense you have? Anti-clock. So this direction of omega, in this case, direction of omega vector is what? Anti-clockwise. This anti-clockwise is same as dot. Angular velocity is what? Anti-clockwise, or you give it with the help of thumb. Angular velocity is always along the axis. So thumb is coming out. Things which are coming out, they are represented by dot. Or you can say k cap, unit vector for this direction. So every time you look at this figure, as long as speed does not change, omega everywhere is what? Same. So this statement is correct. So if something is constant, then what is its differentiation? Differentiation of a constant number is what? 0. That means in uniform circular motion, angular acceleration is what? 0. And that's what the question was. Angular acceleration, is it present in UCM? Answer is no. If it is not present in UCM, it is definitely present in NUCM. We'll see that also. Note down this much. And if you understand this part, then write down yes in the comment box. And if you have any confusion, then write down no. One of you is asking how we got omega same. What is omega? Angular velocity, which is a vector. Vector has got two things, magnitude and direction. How do you decide direction of omega? With the help of right hand. Right hand curl is telling you that direction of omega is all the time along the axis coming out. Along the axis coming out. So direction part is same. Next thing is what? Magnitude. What is omega? Rate of change of angular displacement. V in UCM is always same. Somebody who is at this position, if he moves from this position to this position, let's say he covers an angle of 30 degrees over here, and it takes 5 seconds. If you ask him to move from this position to this position, same angle 30 degree, then since his speed is same, he will take what? Same time. So anywhere you go, if you are covering same angle, time taken will also be what? Same. Same angle in same time, that means your magnitude of omega is also same, which tells us that omega is same. Now, write down this as a statement, the whole thing. In uniform circular motion, as speed of the object is uniform, speed of the object is constant, speed of the object is constant, rate of change of angular displacement, rate of change of angular displacement inside the bracket omega will also be same, and therefore rate of change of angular velocity, therefore rate of change of angular velocity inside the bracket alpha should be 0. Should be 0. Now, if you have non-uniform circular motion, there is no need for me to explain this now, but let's do it fast. Non-uniform circular motion means your speed over here is 5. By the time you reach this position, it becomes 6. By the time you reach this position, it is 7, 8. This is your non-uniform circular motion. Speed is continuously changing. It can increase or decrease. So the speed is changing. That means simple visualization says that to cover this much angle, to cover this much angle, to cover same angle at different places will take different time. So tell me, where will you take less time? If I say that everywhere this angle is same, your speed is 5, you need to cover, let's say, 1 degree angle. Speed is 6, you need to cover 1 degree angle. Speed is 7, you need to cover 1 degree angle. 8, at which place you will take less time? Write down in the comment box. Simple question, simple understanding of physics. Let me check whether you are comfortable with these things or not. You start from this position and you move by 1 degree. I've taken a small angle, so by 1 degree when you move, everywhere I'm asking you to move 1 degree only, but speed is 5, 6, 7, 8. The question I'm asking you, where time will be less. Good, and your answer is correct. It will take less time over here. So what is omega? Omega is d theta by dt. And what I gave you d theta is kind of 1 degree. केवल आपके समझने के लिए भी 1 डिग्री करके कर दिया अपन ने. जैसे जैसे dt पार्ट आपका कम होगा, वैसे वैसे आपका ओमेगा क्या होता जाएगा? ज्यादा होता जाएगा. You're moving fast with it, and therefore it will take you less time to cover this angle. सही सोचा आपने? टाइम कम, इसका मतलब ओमेगा क्या हो गया? ज्यादा. ओमेगा ज्यादा हो गया, that means in NUCM omega is not same. So a non-uniform circular motion like this, omega is not same. And if something is not same, then definitely its differentiation will also cannot be 0. Wrote down like this. This is for non-uniform circular motion. Now tell me this. When you switch on your fan at the beginning, just when you switch it on, is alpha present? Yes or no? When we switch on a fan, the moment you switch it on, is alpha present? Yes or no? Good. Answer is what? Yes. Alpha is present. What is alpha? Rate of change of angular velocity. You can see that the moment you switch it on, its rotational speed. What is rotational speed? Angular velocity. And this angular velocity increases when you switch it on. But does it keep on increasing all the time? No. After a certain time, you find that fan, its blades are rotating with constant speed. That means its angular velocity is what? Constant now. So at that moment, alpha is 0. And then when you switch it off, alpha is again present because it is present in the form of angular retardation. It is decreasing the angular velocity. So with a simple fan, you can take all three parts of alpha. Alpha is present, alpha is 0, and alpha is present in the form of angular retardation. Let's discuss this angular retardation part. What is the direction of omega? Direction of omega is given by this. Along the axis by thumb. Similarly, direction of alpha, angular acceleration, is also along the axis. Write down this. Angular acceleration is a vector quantity. Angular acceleration is a vector quantity and its direction just like that of angular velocity, just like that of angular velocity is along the axis, is along the axis. By the way, suppose I ask you what is the unit of angular acceleration, who will tell me the unit of angular acceleration? Write down in the comment box unit of angular acceleration alpha. So what is omega? Omega was radian per second. Radian per second. So what is alpha? Radian per second square. That's a unit. Now look here. Look at this case. This is the sense of omega, nt. Omega is increasing. Omega omega is decreasing. This arrow means omega is decreasing. Increasing sense of rotation. What is the direction of omega? NT, out. So what is the direction of omega? Direction of omega is dot. Along the axis, out. What is the direction of omega? Along the axis, out. Let's see how many of you can answer this. What is the direction of alpha and what is the direction of alpha in this? This is figure 1 and this is figure 2. First you will answer for figure 1 and then you will answer for figure 2. Figure 1. I just told you that alpha, you can answer with the help of k cap, out, dot, cross. Any way you can answer. If it is in, we say cross. If it is out, we say dot. Or you can say k cap minus k cap. Or you can simply say out or in. Or you can say left or right, up or down, whatever you wish. But let's see if you can. Good. ज़्यादातर आंसर करेक्ट है जितने आए हैं. बहुत सारे लोगों ने आंसर दिया भी नहीं है. जिन्होंने नहीं दिया या थोड़ा बहुत भी कंफ्यूजन है यहां देखना carefully. This is omega. And I told you that alpha, its direction is also along the axis. Now try to visualize this. Something is rotating this way. How should you accelerate it? This way or this way so that you can increase the magnitude? Again, I'm asking the same question. You have, just imagine you have a table fan and its blades are rotating this way. And I ask you to increase the rotational speed. So which way you will exert a force? This way or this way? Well, I guess you will answer, so since blades are already rotating this way and we need to increase the speed, you should support. Support means alpha is coming out. Alpha is coming out, which is dot. Now for this, same fan, same table fan, blades are rotating this way, omega. Rotation of blades, that is what? Omega. But somebody switched off this fan and therefore angular speed is decreasing. So think about it. Fan blades are rotating this way, but if I ask you that the blades are rotating this way, stop these blades. So how will you try to force this thing? By exerting a force, which later on we'll see is nothing but called torque. But forget about torque, simple logic. Blades are rotating this way. You must apply a force in this direction. Oppose it. Oppose the motion this way. This is the opposing motion. Look at the thumb. It's pointing in. Thumb is pointing in. That means angular acceleration is what? Cross. Cross or in. Dot or out. So Direction of angular acceleration is in the direction of angular velocity if omega is increasing, and is opposite if it is decreasing. Those of you who could not answer this part, if you understand this thing, then write down yes in the comment box. So this was the feeling part, and this feeling part is not something which is quite strange. It's not strange means, let's take a simple example which will clear all these things with the help of linear velocities. When you throw an object up, when you throw something up, you know that its v decreases. This is the direction of projection. Object is thrown up, v is decreasing. What is the direction of acceleration? Acceleration is what? Minus g. What is minus? Downward. So v is up, velocity is up, but acceleration is what? Down. So when magnitude of v decreases, acceleration is opposite to the direction of motion. वही चीज यहाँ हो रही है. And then the same object, when it comes down, when the object is coming down, this is the motion, down. As it comes down, v increases. Arrows का मतलब दिमाग में रखना भैया. ये है direction of motion. Object is coming down, and this arrow is telling us that as it comes down, its speed 8, 9, 10, 11, 12, it increases. What is the acceleration? Acceleration, you know, is again what? Minus g. What is minus? Down. So when velocity increases, they both, velocity and acceleration, are in the same direction. वही चीज यहाँ है. अगर आप एंगुलर वेलोसिटी को इंक्रीज करोगे, इसका मतलब है एंगुलर वेलोसिटी और एक्सेलरेशन दोनों का डायरेक्शन सेम होना चाहिए. अगर आप एंगुलर वेलोसिटी को डिक्रीज करोगे तो फिर एंगुलर वेलोसिटी और एक्सेलरेशन दोनों के डायरेक्शंस एक दूसरे के क्या होने चाहिए? ऑपोजिट. कुछ स्पेशल स्ट्रेंज नई चीज नहीं है. इट्स एवरीथिंग व्हिच इज कमिंग फ्रॉम kinematics. Now, इन सारी चीजों को और अच्छे से समझने के लिए लोगों ने क्या बोला है कि काम करो कि यार, अभी हमने थोड़ी देर पहले देखा जैसे जैसे स्पीड बढ़ रही थी, I drew a figure 5, 6, 7, 8. जैसे जैसे स्पीड बढ़ रही थी वैसे वैसे हमने नोटिस किया ओमेगा भी चेंज हो रहा है. मैंने आपसे पूछा था कहां पर ओमेगा सबसे ज्यादा होगा, एंड यू आंसर्ड करेक्टली. उन्होंने बोला इन सारी चीजों को आपस में क्या कर दो? लिंक कर दो. नाउ लेट्स get a relationship between v, which will be called tangential velocity, and omega, which is angular velocity. Write down this relationship between tangential velocity v and angular velocity omega. Relationship between tangential velocity v and angular velocity omega. Look here. अपने ऑब्जेक्ट ने यहां से चलना शुरू किया, and after some time we found it over here. This is the initial position and this is final position. But remember, this much angle is d theta, small angle. This radius is r, this radius is r, this is d theta. An object is moving like this. ऑब्जेक्ट तो पूरा कंटिन्यूसली मूव कर रहा है, हमने क्या बोला कि भाई यहां से लेके यहां तक बात करते हैं बस फॉर डी थीटा। जब ये इनिशियल पोजीशन पर था उस वक्त था टाइम t, जब ये फाइनल पोजीशन पर है तब है टाइम t प्लस डी टी। राइट हियर व्हाट इज द टाइम t ओवर हियर, कितना टाइम बढ़ गया dt, dt टाइम में कितना एंगल कवर किया है d थीटा, व्हाट इज ओमेगा, और आदमी को पता है व्हाट इज ओमेगा, d थीटा डिवाइडेड बाय dt। यहां से यहां तक का टाइम व्हाट इज दैट, फ्रॉम t to t plus dt, this much. Now well, I haven't taught you this, but maybe you have the idea, and therefore I'm asking you. This much is called arc. It's a circular arc. And I'm asking you arc length. What is length of this arc? Which we'll call dl. It's a small angle and therefore the arc is also very small. Let's call it dl. If somebody has the idea of arc length, then write down the formula for arc length. Let's see if you know about these things. Good. Write down the formula. Arc length is radius multiplied by, write down the statement and then you will write this. Arc length is radius multiplied by angle formed by the arc, at the center. Angle formed by the arc at the center. In radians, not in degrees. We take this whole thing in radians. And although I haven't taught you this, but everybody knows about this thing. How do you know this thing? Look here. If I say that take a full arc, then what is the angle this full arc subtends at the center? 2 pi. What is the radius? R. This is 90 pi by 2. Pi. 3 pi by 2. 2 pi. That makes what? Full arc. So if this is a full arc, then what is the length of full arc? Radius multiplied by length of the full arc is what? Radius multiplied by angle formed by the arc at the center, which is what? 2 pi. अब ये चीज तो आप मेरे ख्याल में बहुत पहले से पता होगा. What is the circumference of a circle? 2 pi r. Something which you already know, but now from now onwards remember this. What is the arc length? Radius multiplied by angle formed by the arc at the center. अब यहां पर अपने को आर्क लेंथ मिल गया, हम जब एंगुलर वेलोसिटी की बात कर रहे हैं देन वी यूज डी थीटा अपॉन डी टी। लेकिन अगर मैं आपसे बात करता v टेंजेंशियल वेलोसिटी, तो v क्या हुआ करती है, आपको पता है v होता है रेट ऑफ चेंज ऑफ डिस्प्लेसमेंट व्हिच इज ds by dt, rate of change of displacement ds by dt। if object is moving from this position to this position, then this is ds. Let me make everything clear. Let's use proper terms so that there remains no confusion at all. And then I will erase this figure. थोड़ी देर के लिए बोला कि यार there is nothing small, everything is large. Well, let's take the large values. This is the center. Object यहां से यहां आ गया, some 80 degrees or so. This is arc length, which is L. This is angle theta, which is no longer small angle. And this is displacement. Initial, final. What is displacement? Shortest distance between initial and final points. This is arc length. So object is moving along this circular arc. What is S? Displacement. What is L? Distance. What is distance? Path length. So S and L, they are not same. But just tell me, can I say that ds is dl? Is it correct for me to write this? Can I write ds equals to dl? S is less than L. Everybody can see. Distance, displacement is less than what? Distance. But the question I'm asking is, can I use ds as dl? Yes or no? Good. The answer is yes, we can. Why? What is this d theta? What is d theta? Something which is very, 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 very small. So if somebody is looking for a very small portion, if you are looking for a very small portion, I hope you can see this. If you cannot, let me highlight this part. If somebody is looking for this portion, then for this, your displacement and distance, they both are same. And therefore, I can write ds as what? dl. बहुत छोटे से एंगल के लिए ये जो आर्क है, it can be approximated with a straight line. ये लिखा हुआ है. Which means what? Which means, what is ds? dl. And what is dl? So this becomes r into d theta divided by dt. ds becomes dl. dl we have already calculated is what? r d theta. What is d theta divided by dt? Omega. So with the help of this and with the help of this, we finally arrive at this. What is v? r omega. An important result. Relationship between tangential velocity v angular velocity omega. If you understand V equals to R omega development, then write down yes in the comment box and note down everything. If you have any confusion, simply mention your doubt. Now we have got the relation between V and omega. Write down relationship between acceleration and angular acceleration. Relationship between acceleration and angular acceleration. And it should take just 5 seconds. What is V or omega? What is A? dV by dt. What is dV by dt? R times d omega by dt. Differentiate this. dV by dt, R is a constant moving in a circle, d omega by dt. A, R, what is d omega by dt? Alpha. This is relationship between acceleration and angular acceleration. Note all this and then I'll ask you a question. Now, which acceleration is this? This A, is it tangential acceleration? Is it centripetal acceleration? Or is it total acceleration? What is this A? Write down in the comment box. This A is centripetal, tangential, or total. What type of A is this? let me help you. Let me help you this. Some answers are correct, some are not. UCM, Uniform Circular Motion. मैं चाह रहा हूं कि आप इसके अंदर सारे बेसिक्स को समझ पाओ, बिकॉज फ्रॉम नेक्स्ट वीक विल स्टार्ट रोटेशनल मोशन. सर्कुलर के साथ ही लिंक है, वहां जाकर और भी चीजें आपको क्या होंगी, अच्छी लगेंगी. इसके लॉजिक डेवलप करते हुए चलते हैं, समझ में आएगा आपको. यूसीएम, इन यूसीएम ने आज की क्लास में किया था. अल्फा क्या था, 0. आई होप आपको याद है. यूनिफॉर्म सर्कुलर मोशन में स्पीड चेंज नहीं होती है, हर जगह ये किससे मूव करता है, v से, सेम स्पीड. हर जगह ये किससे मूव करता है, ओमेगा से. तो अगर आपका ओमेगा चेंज नहीं हो रहा है, इसका मतलब है अल्फा क्या होगा, 0. ना अल्फा नहीं है. Now tell me, in this, it's coming from last class, is centripetal force present, yes or no? Fast. Is centripetal force present in this? This much time is enough because we did this thing in the last lecture. Centripetal force is a must. बिना इसके आप सर्कुलर मोशन कर ही नहीं सकते. इसका काम है डायरेक्शन चेंज करना. Fc है. बट व्हाट इज फोर्स? फोर्स क्या होता है भाई, मास इनटू एक्सेलरेशन. कौन सा एक्सेलरेशन, सेंट्रीपिटल. अल्फा नहीं है. तो अगर हम इसको सेंट्रीपिटल बोलते तो प्रॉब्लम हो जाती. If somebody says this is AC and he writes like this, the problem is alpha is 0 in this figure. Alpha is what? 0. If alpha is 0 and had it been centripetal, then AC must be 0. But AC can never be 0. And therefore, this is not correct. So let's talk about total then. Now, do you see tangential acceleration in this? And the answer is no. इस तरफ कितना फोर्स लगता है, Ft. लेकिन क्या है ये UCM? लास्ट क्लास में मैंने आपको समझाया था, टेंजेंशियल क्या करता है, स्पीड को चेंज. व्हाट इज Ft? मास इनटू टेंजेंशियल एक्सेलरेशन. लेकिन हमारे पास यहां पर फोर्स नहीं है. तो यूनिफॉर्म सर्कुलर मोशन का मतलब क्या होता है, यूनिफॉर्म सर्कुलर मोशन का मतलब है आपका टेंजेंशियल एक्सेलरेशन नहीं है. AT is not present. This is AT which is not present. Tangential. Is AT present? What is AT? Capital T. टोटल. टोटल क्या था भाई, अगर दो फोर्स लगेंगे दोनों का वेक्टर सम, दैट वाज टोटल. लेकिन ये तो नहीं है, कंफ्यूज मत होना भाई. टेंजेंशियल नहीं है. क्यों नहीं है, साफ साफ लिखा है यूनिफॉर्म. टेंजेंशियल नहीं है, इसका मतलब सारा का सारा फोर्स कहां है, इस तरफ. अगर सारा का सारा फोर्स इस तरफ है, देन योर AT इज नथिंग बट AC. यूसीएम के अंदर टोटल फोर्स कहां लग रहा होता है, सेंटर की तरफ, क्योंकि टेंजेंशियल होता ही नहीं है. somebody saying that this A is a total, वो फिर से परेशान है. क्यों? if I say this is a total, then मुझको पता है कि इस क्वेश्चन के अंदर अल्फा कितना है रे, 0. If alpha is 0, then A total should be 0. But it cannot be, because A total in this case is what? AC. And AC can never be 0. So this is not correct. Hopefully यहां तक कहानी समझ में आ गई होगी. अल्फा 0 है. और कौन 0 है? And therefore this A is your tangential acceleration. अब ये तो पूरा मैथमेटिकल समझाने का तरीका हो गया. फील करते हैं एक लाइन में. अल्फा का काम क्या था? फैन की स्पीड को बढ़ाना. जब स्विच ऑन किया तो जैसे से आपने फैन की स्पीड को बढ़ाया तो जो ब्लेड्स हैं, look at the tip of the blade. This is a fan suppose in my hand. So as you increase the omega, why? Because alpha is there. तो अगर अल्फा होता तो वो क्या बढ़ा रहा होता? रोटेशन स्पीड. रोटेशन स्पीड बढ़ने का मतलब ये जो पॉइंट है इनकी स्पीड क्या हो रही होती? इंक्रीज. स्पीड बढ़ाने का पार्ट किसके पास आता है? Tangential. If you understand that this A is tangential only, then write down yes in the comment box and write down everything. If you can understand, these are the side notes. This is for you, the way things work. Write down the statement. In A equals to R alpha, in A equals to R alpha, A is tangential acceleration. In A equals to R alpha, A is tangential acceleration. Now, थोड़ी देर के लिए अगर मान लो हम थोड़ा सा एक अच्छे लेवल की ऑब्जेक्टिव एग्जामिनेशन को टारगेट करें, अगर से नीट, जेई और उसके ऊपर भी जेई एडवांस एंड ऑल, what type of questions you can expect? Try to answer this part. कह नहीं सकते, even in schools and all they can ask this. कोशिश करना कि आप आंसर दे पाओ. These are the four options. I'll make it 80. Small d, tangential, which we use in this. 1, 2, 3, 4. Third says centripetal acceleration is this always. Fourth says centripetal acceleration is this only when speed is constant. Look at these four options and tell me which ones are correct. More than one option may be correct. Remember this. Let me read these things for you. First क्या बोलता है? Rate of change of v and its mod. Second क्या बोलता है? सुनना. Rate of change of magnitude of v. This is the difference between first and second. This is rate of change of v and then go for the magnitude. ये क्या बोलता है? Find the magnitude and then go for the rate of change. There is a difference. If somebody wants to write the whole thing in words, you can do that. With this, write down magnitude of rate of change of velocity. This is magnitude of rate of change of velocity. And with the second one, write down this. This is what? Rate of change of magnitude of velocity. Rate of change of magnitude of velocity, which is nothing but rate of change of speed. What is magnitude of velocity? Speed. Tangential क्या change करता है? Speed change करता है. Which means second option is correct. First, it is not. अगर आप ठीक तरह से बोल सकते हैं तो फिर आप करेक्ट आंसर प्रोड्यूस कर सकते हैं. दिस इज फिजिक्स. ये क्या लिखा हुआ है? रेट ऑफ चेंज फाइंड करो एंड देन गो फॉर मैग्नीट्यूड. डू यू नो व्हाट dv by dt इज? अगर आपसे कोई पूछता व्हाट इज dv by dt, dv by dt इसका मतलब क्या होता है? इसका मतलब होता है एक्सेलरेशन. What is this? Are we looking for change of speed? Are we looking for change of magnitude only or change of direction only or both? जब भी आप v वेक्टर यूज कर रहे हो इसका मतलब आप टोटल की बात कर रहे हो. आपको मैग्नीट्यूड भी चाहिए, डायरेक्शन भी चाहिए. This is giving you a capital T. So since this is giving you a capital T, अगर कोई आदमी इसका मॉड लेगा तो उसको क्या मिलेगा? A capital T. You will get this. You will get total acceleration. And therefore it's not correct. अब यहां आते हैं. ये क्या बोल रहा है? ये बोल रहा है AC इज dv by dt। बेसिकली ये क्या बोल रहा है? AC इज AT। नहीं भाई, सेंट्रीपिटल क्या हमेशा टोटल एक्सेलरेशन होता है? नहीं। टोटल यहां पर, ये हमने लास्ट लेक्चर में किया हुआ है। एक फोर्स इधर लग रहा था, दैट वाज FC। एक फोर्स इधर लग रहा था, which was FT, and the resultant was acting in this direction, which was called FT. This we did in last class, and FT was root over FC square plus FT square. ये लास्ट क्लास में मैंने पूछा भी था, आपने बताया भी था करेक्टली। दो वेक्टर है भाई, टेंजेंशियल, ये स्पीड चेंज करता है, ये डायरेक्शन चेंज करता है, इनका ये टोटल है। अब एक्सेलरेशन का मतलब क्या है? मास को हटा दो तो यू विल गेट व्हाट? एक्सेलरेशन। व्हाट इज ए टोटल? ए टोटल देयरफॉर विल बी रूट ओवर AC स्क्वायर प्लस AT स्क्वायर। भाई बच्चों टाइप की चीज है। अब तो ये अपन कर चुके हैं। किसी ने बोला इस तरफ का एक्सेलरेशन क्या होगा? AT। इस तरफ का एक्सेलरेशन क्या होगा? AC। दोनों का वेक्टर सम क्या होगा? ये रहा, A total। दिस इज करेक्ट ऑल द टाइम। व्हाई? क्योंकि ये क्या लिखा हुआ है? ये लिखा हुआ है मैग्नीट्यूड ऑफ टोटल एक्सेलरेशन। ये क्या लिखा हुआ है? मैग्नीट्यूड ऑफ रेट ऑफ चेंज ऑफ वेलोसिटी, विच इज व्हाट? एक्सेलरेशन। ये पूरी चीज यहां तक करेक्ट है। अब लुक एट दिस, इज AC dv by dt, which means I'm basically asking you, is AC AT? This is this. Is AC AT always? No, it's not. Is AC AT? Yes, but when? Only when speed remains what? Same. अगर स्पीड सेम है तो इसका मतलब क्या होता है? स्पीड सेम का मतलब होता है AT कितना है? 0। टेंजेंशियल क्या चेंज करता है? स्पीड। वो आप नहीं चेंज कर रहे हो, स्पीड क्या रखी है आपने? सेम। तो फिर AT नहीं है। अब अगर AT नहीं है तो फिर तो केवल कौन है? केवल AC है। तो इज A टोटल AC देन? यस, yes, and therefore correct thing is what? 2 and 4। पता नहीं कितना समझ में आया होगा। होपफुली only one person has 2 have answered correctly. Rest of you, do you understand this part, this question? Yes or no? कहीं कोई कंफ्यूजन है तो पूछ लो भाई। थोड़ा सा एक थोड़ा बेहतर लेवल का क्वेश्चन दिया है, बहुत ज्यादा हाई फाई भी नहीं है, बट अच्छा है। होपफुली समझ में आया होगा आपको ये। And if you have any confusion, you can simply ask me. Can you explain part 2? Which part 2? Part 2 means option 2. You want me to explain option 2? इस ऑप्शन 2 का मतलब है मैग्नीट्यूड ऑफ V। एक मिनट के अंदर ये पूरी कहानी अगर थोड़ा बहुत भी लोगों को कंफ्यूजन है क्लियर हो जाएगी। देखना भाई, आई एम टेकिंग सम न्यूमेरिकल वैल्यूज, फिर आपको लगेगा कि बहुत इजी था, बट पॉइंट इज चीज इजी है लेकिन प्रेजेंटेशन इस तरह से आते हैं। तो प्रेजेंटेशन वाले पार्ट में कई बार आदमी क्या हो जाता है? शहीद। इधर देखना, अगर कितना इजीली इस चीज को समझ सकते हैं, 2 मिनट की चीज है देखना। यहां पर ये 5 से चल रहा है, तो याद रखना स्पीड है यहां 5 मीटर्स पर सेकेंड, यहां भी 5 है। Everywhere speed is what? Same. I think you understand that 80 is 0. टेंजेंशियल नहीं है, इसीलिए स्पीड क्या है? सेम। अब फिर से देखना, कैन आई से दैट v इज सेम? आप बोलोगे नहीं, v सेम नहीं है। क्यों नहीं है? डायरेक्शन तो लगातार क्या होगा? चेंज। बट विल यू से दैट मॉड ऑफ v इज सेम? Will you say that mod of v is same? And the answer is yes, mod of v is same, definitely. Speed, mod of v, magnitude of v is what? Speed. Speed क्या बनी हुई है? Same. अगर mod v same है, what is this? d. d means what? Change. Change किसका? Magnitude of v. Magnitude of v क्या है? Same. चेंज किसका? सेम चीज का। अरे सेम है तो फिर चेंज कहां है? इसका मतलब 80 क्या होना चाहिए था? dv by dt, मॉड ऑफ v। अब फिर से अगर किसी ने ये बोला होगा dv mod, well everybody, for this figure d of mod of dv, let's say this angle is 90. Let me see how fast you are. d मतलब change, forget about small, d is for us change. What is dv from this position to this position, which you can see is quarter of a circle? Write down fast. देखिए कौन बता पाएगा? 5 5। कुछ कैलकुलेट करने की जरूरत नहीं है, सामने सारी चीजें। No, that means you are still confused. You're confused. You're answering 0. गौर से देखो क्या लिखा हुआ है। फिर से let me explain the whole thing. क्या पूछा है मैंने? देखना, मैंने आपसे क्या पूछा है? dv। आप किस चीज का आंसर दे रहे हो? इसका। इसका मतलब मैंने आपसे क्या पूछा हुआ है? मैंने आपसे पूछा हुआ है d means what? Change. Change in magnitude of v. If I ask you this, change in magnitude of v, magnitude of v चेंज नहीं हो रहा है, तब आप क्या बोलते? 0। मैंने आपसे क्या बोला हुआ है? देखना, मैंने आपसे क्या पूछा है? मैंने आपसे पूछा है get me the magnitude, magnitude किसका? of change in v. That's how we read it. What do I need? Magnitude. इस तरह से रीड करेंगे, magnitude of, next thing is what? Change, then v. इसको रीड करने का तरीका क्या है? Do you see magnitude first? No. ये क्या लिखा हुआ है? Change in what? v. Magnitude. This thing, is there anyone who will answer? Not a single person. Mod of dv, magnitude of change. How do you write change? Final minus initial, और फिर क्या लेना है अपने को? mod. देखते हैं ना, फाइनल मतलब किसका? किसका चेंज निकाल रहे हैं हम लोग? v. v मतलब v final लिखो, और v इनिशियल लिखो और उसका क्या निकाल दो, मॉड फाइनल. कैन यू सी फाइनल इज 5 माइनस आई कैप. जो फाइनल है for this part, this is initial and this is final spot. So for final I can simply say what? For final I can say this, minus of 5 I cap at save time, and initial is what? Up. What is up? J cap minus 5 J cap. क्या आपको पता है आई और जे टाइप की चीजों का मॉड कैसे लेते हैं? ऐसे लेते हैं भाई. व्हाट इज इट? 5√2. जो मैंने आपसे बोला व्हाट इज मॉड ऑफ डीवी? 5√2. व्हाट इज डी मॉड वी? 0. Do you understand it? Yes or no? And then you can leave. Thank you.